Hello everyone, good morning. I hope you people are doing good and well. So today in the class, we will be learning or we will be revising modern physics through questions. Okay? This is quite an easy topic, I would say. If you really know the formula and basic concepts, then you will be able to solve all the questions, and this is a high weightage topic. So today I have included a number of questions, and through questions we will be taking hold of concepts. Okay? Chalo. Let's start with questions. So this is the very first question that you have to do. Take your time, do it. Take, max 1 minute. Okay? If you remember, you will be able to do. If you don't remember, again, no worries, because in this class, we are revising things. So I will take you through formulas, concepts, everything. But for 1 minute, you need to try. You need to recall. Okay, I got some answers. One feels correct, another one is incorrect. Okay, let's revise the concept. What is this basically? So, we must have studied if there is atom in gaseous state. If you get atom in gaseous state, then if you allow light to pass through it, it's quite common phenomena that light is falling on gaseous atoms, and then it will get excited. After getting excited, again it will come back to the ground state within some fraction of seconds, to the range of within the time 10 to the power minus 8 second. It will come back to ground state, releasing energy, and it releases energy in different wavelengths ranges. And according to that, we have defined certain series. What are those? देखो यहाँ पे मैंने सारे जैसे सपोज कर लो, यू आर ओके ओके आई हैव इंसर्टेड रॉन्ग डायग्राम. नो, हियर आई हैव डन इट. तो व्हाट इज द केस हियर? जैसे देख लो, हमारे पास सपोज कर लो एक एटम इन ग्राउंड स्टेट. लेट्स टॉक अबाउट द हाइड्रोजन एटम, क्योंकि सिंपलेस्ट एटम इज दिस, एंड दैट इज व्हाई it's easy to read its spectra. That is why we read for hydrogen atom. So if that is in ground state, you give it energy, it will go to excited state. It can go to n equal to 2, 3, 4, 5. And wherever it is going, from there it will come back. And it can come back in different ways. Suppose Karlo, it has got excited to n equal to 4, yani ki it's here. And what is the way of this excited atom coming back to ground state? Maybe it will directly jump to the ground state. Maybe first it will go here, and then here. Maybe first it will go here and then here. So there are different ways in which excited atom can come back to the ground state. Now, in these transitions, what is happening? Energy is getting released because it absorbed energy to reach to the excited state. When it is coming back to the ground state, it will release the same energy. So here it released some energy. In this process, it will release three successive energies. First, energy difference this, then energy difference this, then energy difference this. So three different wavelengths will get released. And here, first this and then this. So another two different wavelengths. So overall, if uh, atom got excited to n equal to 4, it will come back to ground state releasing 6 different form of energy. It's possible. Okay. So sometimes question is also asked like how many transitions are possible. So to calculate it manually may feel difficult, because if it is said excited atom is in n equal to 5, tell me the number of different wavelengths of light that can get emitted. Okay. So how we will calculate it easily? Use the formula NC2. So if your atom is getting excited to n equal to 4, put here 4. So 4C2. Formula kya hoga? 4 factorial by 4 minus 2 factorial, 2 factorial. So this is 4 into 3 into 2 divided by 2 factorial, that is 2 into 1 into 2 into 1. So if you will solve it, you will get 6. And we have seen here 6 different transitions are possible, and hence 6 different wavelengths. Done it? And if n equal to 5, then you will calculate 5C2. NC2 का general formula क्या है? N factorial divided by n minus 2 factorial, 2 factorial. This is one thing. Coming back to our question हमारा ये था, देखो, I will explain it here only. Let me erase everything from the thing. So when atom is excited and it is in n equal to 2 or n equal to 3 or n equal to 4 and so on, and if the excited atom is jumping directly to n equal to 1, that is to the ground state, then whatever energy is getting released will lie in the Lyman series. So Lyman series का मतलब क्या होता है? Transition will be happening from n greater than 1 to n equal to 1. ठीक है, यानी कि 2 से 1, 3 से 1, 4 से 1, like that. This is Lyman series. Done it? What about then there is another series. If excited atom jumps from any excited state to n equal to 2. So if n is greater than 2 and it is jumping to n equal to 2, then we will get another series. This is called Balmer series. And Balmer series lies in the visible region. जैसे यहाँ पे देखो colorful lights दिखाए गए. So this lie in the visible region. Lyman series lie in what? This lies in ultraviolet region. ठीक है? Done it? Now let's see here. This is Balmer series. NF equal to 2 के लिए, and then from n equal to any other state to n equal to 3, then you will get another series again, and that is called Paschen series. So n greater than 3 say, it will jump back to n equal to 3, then we will get Paschen series, and so on. Then we will get bracket series. Bracket series means n greater than 4 से jump करेगा to n equal to 4, then we get bracket series. ठीक है? And finally what we get is, finally we get after bracket we get P fund series, and for P fund series jumping will be from n greater than 5 to n equal to 5. ठीक है? So this is these are all the series which we will get. NF equal to 1, final अगर state jumping state 1 है Lyman series, directly it is Paschen. If it is coming back to 4, then bracket. When it is coming to NF equal to I mean to 5, it is P fund. What was our yes, this was the question. The spectral series which correspond to electronic transition from N to this to the level N1 equal to 4. So 4 में 4 को जब 1 को transition कर रहा था, we called it Lyman series. 2 को transition कर रहा था, we called it Balmer series. 3 को transition कर रहा था, we called it bracket series, right? नहीं, sorry, Paschen series. And when n equal to 4, it was bracket series. ठीक है? So answer will be 2. I hope it is clear. And you can calculate wavelength by using this formula. Wavelength of any series. So formula is 1 by lambda equal to R, 1 by NF ka square minus 1 by NI ka square. R is what? Your Rydberg constant. ठीक है? इसका value 1.007 something into 10 to the power 7 होता है. Meter inverse. Okay? So this is your R. Now if you have to calculate this wavelength for hydrogen like element, that is if suppose कर लो this is helium 2 plus, so helium 2 plus is what? He आई मीन हाइड्रोजन लाइक एलिमेंट कहने का मतलब क्या है? हाइड्रोजन लाइक एलिमेंट कहने का मतलब है इसके न्यूक्लियस में देयर विल बी वन प्रोटॉन, ठीक है? हीलियम और इट हैज, सॉरी नॉट वन प्रोटॉन, प्रोटॉन को रिमूव करना पॉसिबल नहीं है, लेट्स नॉट टॉक अबाउट द प्रोटॉन थिंग. हाइड्रोजन लाइक एलिमेंट मीन्स इट विल हैव सिंगल इलेक्ट्रॉन इन इट्स सेल, ठीक है? सो इफ यू टॉक अबाउट हाइड्रोजन के बाद हीलियम, इट हैज टू इलेक्ट्रॉन, He2+ करेंगे तो दोनों इलेक्ट्रॉन चला जाएगा, इट्स नॉट हाइड्रोजन लाइक. He2+ इज कॉल्ड अल्फा पार्टिकल थिंग, nucleus of He2+ is called alpha particle thing. But He plus will be hydrogen like, because in the cell of He plus there is only one electron, single electron. So this is what? This is hydrogen like. So for hydrogen like element, if you have to use this formula, use it with slight modification, and that modification is 1 by lambda equal to arc z का square, ठीक है? 1 by nf का square minus 1 by ni का square. What is this Z? Z is the atomic number. So for hydrogen, Z is 1. For hydrogen like element, Z will be different. So for helium, it is 2. So Z square will become 4. Accordingly, you will calculate wavelength. Okay? So these all things you need to remember. This thing, Lyman series in ultraviolet region, Paschen bracket, P-fund, they are in infrared region, and Balmer series is in what? It is in visible region. So ये सारे information अब हमें पता है, ठीक है? चलो हमने रिवाइज किया. Now let's do this question. This is from the nuclear reactor thing. Do it. One right and one wrong answers. Okay. Others, please also let me know. If you know the fact, you would be able to do this. Yes, Shruti, correct. So why we use water as a coolant in nuclear reactor? Because in nuclear reactor, जैसे, yes, Raju, correct. So in nuclear reactor, what happens? It has tendency, I mean, it will heat up with time, and you need to cool it so that you can control reactions happening. Sai, no, correct answer will be B actually. So we need to cool the reactor, and for cooling the reactor, we will give it something that will absorb its heat. Then why water is used? Because in thermodynamics also there is one case of that is land bridge. You must have studied that thing. There also we find the application of high specific heat capacity of water. So basically क्या होगा ना, if water has high heat capacity, what does it mean? It means that to heat water by delta T temperature, how much heat we need to supply? Q equal to ms delta T. Okay? So if S is higher, that is a specific heat capacity, then Q will be higher. And if Q is higher, what does it mean? It means that suppose करो 1 degree से temperature को rise करना है. So for that you need to supply ms amount of heat. And if S is higher, this ms is higher. So to raise the temperature of water by 1 degree centigrade, it is requiring more amount of heat. So it will absorb more heat of the reactor, which is a required case in case of nuclear reactor, right? We want heat to go away. We want to give heat the exit, right? So for that, we will supply the reactor with such a thing that will absorb most of its heat, or efficiently it will absorb, or more it will absorb. And that is possible for the water because it has high heat capacity. Its temperature will rise by 1 degree, but for 1 degree rise, it will absorb more heat. And that is why we are using water as a coolant. If we are using something which has low specific heat capacity, तब क्या होगा? It will get heat up itself after absorbing even little amount of heat. So that won't be efficient for our reactor. And that is why correct option is what? ठीक है, चलो, now let's do this question. Everyone solve it. So far, I received one correct and one wrong answers. Yes. Yes, Shruti. Yes, correct है. Very good. चलो ठीक है, करते हैं. So what are the things? Slow neutrons can cause fission in uranium 235, right? We have studied this thing. Nuclear reactor के अंदर reaction तब होता है when we bombard uranium 235 with slow moving neutron. That's a fact. It happens. So first is correct. Second, alpha rays are helium nuclei. Yes, alpha rays तुम्हारा क्या है? He2 plus. He2 plus means helium devoid of two electrons, that is helium nucleus. So yes, B is also correct. Beta rays are fast moving electrons or positrons. Yes, in beta decay either we get proton released, sorry, not proton, proton cannot get released, sorry. In beta decay, we either get electron getting emitted or we get positron getting emitted. Electron and positron में difference क्या है? They have the same mass, but their charges are of opposite nature. ठीक है, one is positive, another is negative. Done. Positron is different from proton because proton mass is 10 to the power 6 times heavier than that of electron, right? But here these two share the same mass. So C also looks correct. Yes. Gamma rays are electromagnetic radiation of wavelength larger than X-rays. Energy of gamma rays is greater than energy of X-ray. We already know this. Gamma ray is highly energetic radiation. And energy का formula क्या होता है? Hc by lambda greater than Hc by lambda of X-ray. So definitely, energy से wavelength inversely proportional है. So wavelength of gamma radiation will be less than wavelength of X radiation, that is X rays. ठीक है. So D is what? Incorrect. Correct option will be A. ठीक है. चलो. Now let's do this question. Okay, I received one answer that feels incorrect. Oh, two answers incorrect. सही से solve करो. Okay, let's end the discussion here. Let's do it together now. ठीक है? Let's check it. सहारा नहीं, गलत आ रहा है, चेक कर लो एक बार कैलकुलेशन, देखो क्या होगा. थ्री वेवलेंथ्स आर गेटिंग एमिटेड, lambda 1, lambda 2, lambda 3. Lambda 1 is getting emitted. Why? Because electron initially having energy, or initially it is residing in the orbit whose energy is minus 5e by 2, and finally it is coming back to energy minus 4e. So it is jumping from high energy state to low energy state. It will release energy, and it is releasing energy of wavelength lambda 1. So energy getting emitted is equal to hc by lambda 1, and this will be equal to difference of energies between the orbits, right? So if you calculate the difference over here, it will be how much? Minus 5e by 2 plus 4e. So this is equal to 3e by 2. Okay? So what will be the value of lambda 1? Lambda 1, if you see, 2hc by 3e. This is your lambda 1. Now, if you calculate lambda 2, it is because of this energy getting released. So hc by lambda 2, now you same thing you do. Energy difference आप देख लो दोनों सेल के बीच का, that is E basically, minus 2e plus 3, so that is E. And this implies that lambda 2 will be equal to hc by E. ठीक है? And similarly, you calculate lambda 3, hc by lambda 3 will be equal to how much? Just see the energy difference. So here energy difference is how much? This is equal to 2e. And if you calculate this one, lambda 3 is hc by 2e. Now we have the values, right? So check the values. Lambda 2 and lambda 3 share a relation. Lambda 2 is equal to 2 lambda 3. है ना? Because if you're going to multiply SC by 2E with 2, you will be getting lambda 2, right? So this relation holds true, and lambda 2 is greater than lambda 1. Lambda 2 is this. Lambda 1 is how much? It is 0.6 HC by E. And this is 1 HC by E. So definitely lambda 2 is what? It is greater than lambda 1. So correct relation will be which one? It will be fourth one. दिस इज हाउ वी कैलकुलेट एनर्जी. जैसे आप मैंने जो स्पेक्ट्रा डिस्कस किया ना इन द वेरी फर्स्ट क्वेश्चन, वहां भी ट्रांजिशंस वेर हैपनिंग. सो व्हेन इलेक्ट्रॉन जंप फ्रॉम हायर energy state to lower energy state, it releases energy, and that energy is equal to the difference of energy of the orbits. So final orbit minus initial orbit का जो energy था, that difference will be equal to energy of photon getting emitted. Okay? And similarly, if you have to make an electron jump from ground state to excited state, you need to supply it with energy, because it is initially in lower energy state and finally it has to go up. आपने पढ़ा है ना ये चीज, जैसे ग्राउंड स्टेट की एनर्जी क्या होती है? -13.6 इलेक्ट्रॉन वोल्ट फॉर हाइड्रोजन. And when you will go up, this negativity will decrease. This negativity is going to decrease. It means what? Energy is increasing, right? At n equal to infinity, that is in ionized state, energy is what? Zero. So as you move from orbit closer to the nucleus to orbit which is far away from nucleus, energy will decrease. ऐसे भी आप सोच सकते हो, यहाँ nucleus it has a positive charge. Electron which is closer to the nucleus, electron which is closer to the nucleus is more attracted, its potential energy will be negative, more negative. So more attraction means more negative. As the orbit size will increase, this attractive force will decrease and hence more energy. So if something is in attracted state, its energy is what? Its energy is less. Done it? So this is this. Now let's do this questions. This question, let's try. Okay, one correct answer I received. Shruti, yes, correct. Very good. Okay. So far, two answers, one correct, one incorrect. Okay. Let me end the poll. Let me tell you what mistakes you may be doing. I mean, first statement को आप पढ़ो. Atoms are electrically neutral. Yes, they are. As they contain equal number of positive and negative charges. Yes, that's true. ठीक है. राजू, नहीं दोनों incorrect तो नहीं होंगे ना? यहाँ पे ध्यान से देखो, एटम इज इलेक्ट्रिकली न्यूट्रल. यस इट इज, बिकॉज इसके न्यूक्लियस में जितना प्रोटॉन होता है, जितना पॉजिटिव चार्ज होता है, सेम अमाउंट ऑफ इलेक्ट्रॉन इज ऑर्बिटिंग अराउंड. ठीक है दीपू, सेकंड स्टेटमेंट करेक्ट नहीं है ना? केमिस्ट्री तुम लोग पढ़े हो ना? केमिस्ट्री में यू मस्ट हैव स्टडीड अनस्टेबल एटम्स. नॉट ऑल एटम्स आर स्टेबल, है ना? विच एटम्स आर स्टेबल, विच आई मीन sodium itself, it's not that stable. Cgm, it's not stable, because if you keep it in the outside environment, it has tendency to react very easily, है ना? So inert gases are there. Inert पढ़ा है ना ग्रुप 18? inert gases क्या होते हैं? They don't react. In fact, they don't. Under very high or under very unpleasant scenarios, maybe we will make them react with something. But naturally, if you're keeping it free in the environment, they won't react. They're inert. They're stable. Inert means they're stable. वो अपनी आइडेंटिटी मेंटेन करके रख रहे. दे आर नॉट चेंजिंग देयर आइडेंटिटी. आई मीन दे आर नॉट कंबाइनिंग और मीटिंग विद समबडी एंड बिकमिंग समबडी एल्स. नो. यस नव्यश्री, करेक्ट है. ठीक है. सो atoms may be stable or unstable. Atoms of each element are stable? No. And emit their characteristic spectrum? Yes. Every atom emit their characteristic spectrum, but it doesn't mean they are stable. ठीक है. Atoms are unstable. Atoms are there. So statement 2 is what? Incorrect. Which option will be correct? One is correct, other is incorrect. Yes, option C. Now do this. बस सही से करो सभी लोग. One incorrect answer I received. Raju, नहीं, doesn't feel like correct. सही से करो. अल्फा अल्फा डीके में क्या होता है? राजू, यस, नाउ इट्स करेक्ट. अल्फा डीके में क्या होता है बताओ? अगर एक्स है तुम्हारे पास, एटॉमिक नंबर जेड है, मास नंबर ए है, देन इन अल्फा डीके व्हाट विल हैपन? its mass number will get decreased by 4, and atomic number by 2, an alpha particle will get released, that is He2 plus. ठीक है, this is going to happen, right? What will happen in beta minus decay? In beta minus decay, what happens? In beta minus decay, overall, one neutron will get converted into proton plus electron. ठीक है? So basically, neutron is getting converted into proton. Overall mass number will not change because mass number क्या होता है? Sum of proton plus neutron. So if one neutron is getting converted into proton, P plus N number is not going to change. But atomic number will change, which is equal to the number of what? Equal to the number of proton. So if one neutron is getting converted into proton, mass number will remain same, atomic number will increase by 1. ठीक है? What will happen? This thing will happen in beta minus decay. What will happen in beta plus decay? Proton will get converted into electron, positron plus yes, positron plus what? Neutron. ठीक है? This will get converted into positron plus neutron. Now here what will happen? One proton is getting consumed, right? So Z will decrease by 1. And what else is there? Nothing. एक चीज और यहाँ पे याद रखना, यहाँ से एक और क्वेश्चन आ सकता है, जैसे इन बीटा माइनस टी के न्यूट्रॉन इज गेटिंग कन्वर्टेड इनटू प्रोटॉन प्लस इलेक्ट्रॉन. This reaction is possible both inside the nucleus and outside the nucleus. Even if the environment of nucleus is not present, this reaction can happen. But this reaction, which is proton getting converted into neutron and positron, this is only possible inside the nucleus. This question came once. So this is only possible inside the nucleus. And the reason being, यहाँ पे delta M जब निकालोगे ना, mass defect, this is negative here actually. So naturally, which reaction is possible? Where the mass defect is positive. That is, energy will get released. But in this process, mass defect is negative. So it needs extra energy or extra support or help. And that is why it needs the environment of nucleus for this reaction to happen. ठीक है? So ये चीज याद रखना. अब यहाँ पे चलो डील करते हैं हम. X हमारे पास क्या था? X here is 82 to 90, right? So when alpha particle will get released, what will happen? Y क्या होगा? Y के पास atomic number will be Z and mass number will be 286. ठीक है? Now what is happening? Now beta decay is happening. है ना? Sorry, Y तुम्हारा Y ये बना and after that beta plus decay is happening, right? एक second, X went into Y with alpha decay and then Y will go to Z with positron is getting released, right? E plus. So if E plus is getting released, what does it mean? Beta plus decay is happening. And here what will happen? One proton will get converted into neutron. So जो तुम्हारा Z बनने वाला है, proton is getting converted into the neutron. So atomic number will decrease and that will become how much? 79. And this will be how much? This will be, it is 286. It will remain same. So here what happened? E plus got released, then became Z. Now Z will come to P. Z is coming to P by beta minus decay. So in beta minus decay, neutron will get converted to proton. Again, atomic number will increase by 1. So 80. And here this is 286. And finally, what is happening? One E minus is getting released. So E minus is getting released means neutron is getting converted to proton. Again, when Q will happen, Q will become, mass number will increase by 1. And atomic number will increase by 1, mass number will remain same. So final answer should be 286, 81. Answer should be 4. But there is a confusion here. Confusion ये है कि जो E minus sign यहाँ पे दिया है ना, इसको दूसरे वे में भी रीड कर सकते हैं, इलेक्ट्रॉन कैप्चर भी बोल सकते हैं यहाँ पे. लेकिन सिंस तुम लोगों को इलेक्ट्रॉन कैप्चर पढ़ना नहीं है, वी हैव नॉट डिस्कस्ड इट एनीवेयर, दैट इज व्हाई व्हाट वी विल डू इट, जहां भी ई प्लस साइन दिख रहा है, we will assume this is beta plus decay. Wherever you see E minus getting released means beta minus. Electron capture is a different thing, where a nucleus is capturing electron, and if nucleus will capture electron, one proton will get released basically. So that's a different game. Don't go into that. I will say कि इस क्वेश्चन में बहुत जगह दिया है कि क्वेश्चन इज रॉन्ग, बट आई वुड से according to our syllabus, E plus means positron, E negative means this electron getting released in beta minus decay. And if we follow the thing, we will be getting the answer, which is 28681. ठीक है, so this is your correct answer, and this is the whole revision: alpha decay, beta minus decay, beta plus decay. ठीक है, चलो, now do this question. Okay, I got one answer. And it feels correct. Okay, three different answers. देखो, these are directly coming from formula, so you should not be doing mistake. I mean, this is a big crime if you're doing. चलो, पहले मैं फॉर्मूला तुम लोगों को दिखाती हूँ. फॉर्मूला क्या है, कैसे पढ़ोगे बताओ. श्रुति. ओके. राजू. ठीक है, देखते हैं क्या होगा. एनर्जी क्या होता है. द ग्राउंड स्टेट एनर्जी इज गिवन 13.6 minus 13.6 it will be. ठीक है, the energy needed to ionize hydrogen atom from its second excited state. So this is ground state. Ground state means n equal to 1. First excited state means n equal to 2. Second excited state means what? Second excited state का मतलब n equal to 3. You have to be careful. This is n equal to 3. So this is first excited state, and this is second excited state, and so on. Done it? So you have to ionize atom from its second excited state. What will be the answer? फर्स्ट का एनर्जी इतना है, सेकंड का एनर्जी कितना होगा, -13.6/4. And what will be the energy of third one? -13.6/9. So it will be around -1.51 electron volt. And if this is the energy here, -1.51 electron volt, and you need to ionize it. Ionize ka matlab, you want to make its energy 0. So how much energy you will be supplying to it? +1.51 electron volt. So correct answer should be what? एक सेकेंड पहले आंसर को चलते. Correct answer will be A. So Raju, your answer was correct. है ना. चलो, सो यू नीड टू रिमेम्बर फॉर्मूलाज. देखो यहाँ पे मैंने सारे फॉर्मूलाज लिख दिए हैं, बीट फॉर एनर्जी एंड ऑल. सो एनर्जी का जनरल फॉर्मूला क्या लिखोगे, -13.6 जेड बाई एन स्क्वायर इलेक्ट्रॉन वोल्ट. नाउ व्हाई दिस जेड हैव इंक्लूडेड फॉर हाइड्रोजन लाइक एलिमेंट. दिस सीट इज वेरी इंपॉर्टेंट. हाइड्रोजन लाइक एलिमेंट के लिए अगर पूछता है तो एनर्जी में यहाँ पे जेड का फैक्टर आएगा. ठीक है, एंड हियर नॉट जेड का फैक्टर, जेड स्क्वायर का फैक्टर आएगा. सॉरी, this should be z ka square. So -13.6 z square by n square electron volt. Electron volt is the unit of energy, and 1 electron volt is equal to 1.6 into 10 to the power -19 joule. This thing you should also remember. Now, if you have to calculate nth orbit, the radius 0.53 n square by z angstrom. ठीक है, z again for hydrogen like element, velocity in nth orbit 2.18 into 10 to the power 6 z by n. ठीक है, and this is what Rydberg constant. Rydberg constant is 1.03 into 10 to the power 7 जेड का स्क्वायर. ठीक है, मैंने वहां पे जेड का स्क्वायर बताया था या सिंपल जेड कर दिया था, एक बार चेक कर लेना. जेड का स्क्वायर होगा. ठीक है, जैसे 1/λ इज इक्वल टू आर जेड स्क्वायर 1/n फाइनल माइनस 1/n इनिशियल. ठीक है, डन है. So this is the whole formula and this thing you should remember. ठीक है, just give me 1 second. ठीक है, सो चलो इस चीज को तुम लोग याद कर लेना. नाउ लेट्स डू नेक्स्ट क्वेश्चन. यस. Angular momentum of an electron moving in orbit of hydrogen atom is 1.5 h by pi. मैं लिख रही हूँ so that if it's not visible then the energy in the same orbit is how much? That is the question. What is the formula of angular momentum in nth orbit? nh by 2 pi. This is the formula of angular momentum in nth orbit of hydrogen atom. ठीक है, अब बताओ what will be the energy if angular momentum is given like this. If angular momentum in that orbit is this much, what will be energy in that orbit? That's okay. राजू, एक बार और ध्यान से देखो. ओके, नाउ आई विल एंड द पोल. तुम लोग ऐसे चेक करो ना, एंगुलर मोमेंटम 1.5 h by pi दिया है. Let's calculate the what is the number of orbit. So angular momentum का formula मैंने क्या बताया? nh by 2 pi and this is equal to 1.5 h by pi. So 2 को इधर I mean h by pi को cancel करो. So n is equal to how much? 1.5 into 2, that is third. So it is talking about third orbit. And in third orbit, what will be the energy? Minus 13.6 by 9. Done. This is hydrogen atom की बात हो रही है. तो simply minus 13.6 by n square. N is 3. This is 9 and this will give you how much? Minus 1.5 electron volt. So correct answer will be A. ठीक है. Please practice more question of this chapter. They're simply formula based. चलो अब इसका आंसर मुझे बता दो. Okay. 2 answers, 1, 2 correct, 2 incorrect, 4 answers I received. Okay, let us end the poll here because you simply have to put in the formula. In a hydrogen spectrum, shortest wavelength in Balmer series. Balmer series का मतलब क्या है? बाल्मर सीरीज का मतलब है इलेक्ट्रॉन ट्रांजिशनिंग फ्रॉम एनी ऑर्बिट टू n इक्वल टू 2, फ्रॉम एनी ऑर्बिट टू n इक्वल टू 2. एंड शॉर्टेस्ट वेवलेंथ का मतलब क्या होता है? व्हाट इज द मीनिंग ऑफ शॉर्टेस्ट वेवलेंथ? एथिन, यस, दैट्स करेक्ट. सो शॉर्टेस्ट वेवलेंथ का मतलब क्या है? मीन्स हाईएस्ट एनर्जी वाला वेवलेंथ, राइट? Wavelength is short when energy is the highest, and when transitioning energy will be highest for the Balmer series. This energy, this energy, this energy. यहाँ पे कौन सबसे ज्यादा है? This one. And more higher amount of energy we will get if transition is happening from more far away orbit, right? And the orbit most far away will be taken as n equal to infinity. ठीक है. So 1 by lambda equal to what you are going to write? Rydberg constant. Shortest wavelength in Balmer series को आप क्या लिखोगे? 1 by lambda r. This is equal to how much? N final. This is your n equal to 2. So 1 by 4 minus 1 by infinity. ठीक है. So 1 by lambda is equal to r by 4. So lambda is equal to 4 by r. This is the shortest wavelength in Balmer series. Now the shortest wavelength in the bracket series will be what? So bracket series का मतलब क्या था? It was jumping from where to where? ये बताओ. First is Lyman when coming from uh, any orbit to one. Second is Balmer. Third is your what? Paschen, I feel. है ना? On and fourth one is your what? Bracket series. And bracket series में क्या होगा? Electron is transitioning from any higher orbit to n equal to 4. And in that case, shortest wavelength in case of bracket series will be how much? It will be equal to r 1 by 4 का square minus 1 by infinity. ठीक है. So this is equal to 1 by lambda br is equal to r by 16. So lambda br is equal to how much? 16 by r. And 4 by r is equal to how much? Lambda. So this is equal to 4 lambda. Done it? So correct answer will be this. Whenever you are asked shortest wavelength, go for initial with n equal to infinity. Whenever shortest wavelength is asked, in n initial is n equal to infinity. Whenever you are asked for the longest wavelength, go for the nearest transition. I mean Balmer series के लिए nearest transition क्या है? 3 से 2. Done it. And in Lyman series, if you talk about nearest transition, then it is for n equal to 2 to 1. So this will give you the longest wavelength and so on. Done it. So this is done. Now let's do this. Let's go to the de Broglie wavelength calculation. What is the formula of de Broglie wavelength? That is equal to h by p, where p is the linear momentum. And if you have to relate P with kinetic energy, P को कैसे लिखते हैं? 2mk. ठीक है. In some questions kinetic energy is given and then you are asked to calculate lambda. So P की जगह क्या रख सकते हो? रूट अंडर 2mk. ठीक है. Okay. Shruti, yes, that's correct. Very good. So I will end the poll here so that I can make you understand if you're getting stuck. Okay. So what is the thing here? There is an electron and alpha particle. They are accelerated by some potential. Same potential here it's given. Lambda E and lambda alpha denote the de Broglie wavelength of the electron and alpha particle, respectively. Then you have to find relation between these two. Shashank, there is a bit of mistake. See here. So what is the thing that is to be used here? Whenever you accelerate Q charge, any Q charge, through potential difference V, its kinetic energy increases, and that is equal to QV electron volt. This is the kinetic energy. So here electron is accelerated through V potential difference. Its kinetic energy will become EV, and here alpha particle is also accelerated by the same potential, and the charge on alpha particle is what? That is double the charge of electron, because that is He2 plus. So that will be equal to 2eV. Okay. Now you have to calculate the ratio of their wavelength. So wavelength of electron को आप क्या लिखोगे? H by 2 mass of electron, let's say that is m, into kinetic energy of electron, that is ev. ठीक है. What is the alpha particle का wavelength? H by 2 into mass of alpha particle. Alpha particle क्या है? Helium का nucleus है. In helium nucleus there are two protons and two neutrons. So for the mass of what electron we can say, but we cannot say like this, क्योंकि इलेक्ट्रॉन का मास क्या होता है? 10 to the power minus 31 kg के रेंज में होता है. And mass of neutron and proton is of the range of what? 10 to the power minus 27 kg. ठीक है. So here mass of alpha particle is far greater than that of mass of electron here. ठीक है. And this is 2eV. Now what you infer from these two relations? लैम्डा ई जो होगा उसके नीचे में क्या है? 2me into ev, and here 2m alpha, which is far greater than that of me. It means lambda alpha will be what? Very much smaller. ठीक है. Because wavelength is inversely proportional to mass, and mass of alpha particle is far greater than that of mass of electron. So here I will say lambda e is far greater than lambda alpha. ठीक है. So option A suits here. Option A will be correct. Now let's do this question. This is from your what? Dual nature of radiation. Take your time, do it. Okay, let me see your answers. Nobody? Let me end the poll here. This is a basic thing in, what is that called? Photoelectric effect. So whenever light is allowed to fall on a photosensitive material, let's say energy of light is E. Very a Sorry, I got disconnected. Let me explain this question. After that, we will leave. Okay. So, what is happening over here? Energy is falling like this, and then its work function is phi. Then they actually in photoelectric effect, collision happens between photon and atom. So photon means these packets of energy in the light, because in photoelectric effect we consider light as a particle. So these particles are nothing but photon. So during photoelectric effect, what happens? Photon and atom collides. And during this collision, photon transfer its energy to the atom. So how much energy it can transfer? E. And how much energy atom requires to, uh, to give its electron outside, that is phi. So E से phi energy तो चला जाएगा in knocking electron out, and whatever energy is left will stay with emitted electron as kinetic energy. So kinetic energy maximum value can be equal to how much? E minus phi, where E is the energy of light and phi is what? Phi is your work function. What we were asked? यस. सो बेसिकली यहाँ पे एनर्जी को, ओके, वेवलेंथ इज गिवन एच सी बाई आई. सो एनर्जी निकालना पड़ेगा. एनर्जी को आप क्या लिखोगे? एच सी बाई लैम्डा. सो एच सी बाई लैम्डा का वैल्यू क्या गिवन है? एच सी बाई ई. सो दिस विल बिकम योर ई. सो हियर एनर्जी वैल्यू इज इक्वल टू ई. सो ई माइनस फाइव इज इक्वल टू के मैक्स. ठीक है. सो दिस इज व्हाट वी आर गोइंग टू गेट. Yes, Sasam, correct. So this is the equation we used. कल के क्लास में what I will do is photoelectric effect के basic formulas के through I will revise, and after that we will be starting with new topic. ठीक है. So again tomorrow we will be exercising or we will be doing lots of questions with revision of concepts. ठीक है. चलो. Take care of yourself, everyone, and keep solving more number of questions. Please, everybody, take care of this thing. Solve as many number of questions as you can. Chalo. Bye, everyone. Take care.